All right, so we are on to page 2. Hopefully you've taken some time to work through these with your neighbors as much as you can. Remember, you're just doing your best to see how well you can apply what we've learned to what we're learning now. So in question 8, it says in a normal distribution, 95% of the data lies within blank standard deviations of the mean. And for this, we want to think back to the empirical rule. When we did the empirical rule, we learned that that was 2 standard deviations of the mean. But that empirical rule is a nice, neat little rule that was made that kind of estimates a little bit and rounds some numbers. So actually, 2 standard deviations in the 95%, it is more of like it's an estimated guesstimate that just is nice and pretty and easy to use, but it is actually not the most accurate. So now, as we move on, we want to become more accurate in our calculations, especially when we are determining confidence intervals, right? If I want to be confident, I don't want to round too much. So now this value, the number 2, that is what is called a critical value. Critical value tells you how close or far you close or far you are from the mean. How many standard deviations away you are, right? That's what a z-score tells us, basically. But our critical value is the one that allows us to go up by that many, down by that many, to create an interval in the middle, so that we're finding where the middle, whatever percent of data lies. So now, using either table A or inverse norm, find all of these critical values. Well, I'm going to draw a table, a normal distribution curve, just so we can kind of think about what it is that we want. If I want for the first one, say the middle 80%, then I need to know what the critical value is here and here. And obviously, because the normal distribution curve is symmetric, right, it should be the same on both sides, just that this one will be the positive and this one is the negative. Think about how we could find this value, though, using our table. There's actually probably like 2 different ways that I'd say would be the easiest. But think about what is left over from the middle 80%, right? If you have the middle 80%, you're left with 10% on each tail. So we have 10% above and 10% below. How could that then help you to find the z-score for that value? Well, I'm just thinking if we go look for 0.1000 on our z-table, we can work backwards and find the z-score. Of course, you could also do inverse norm on your calculator and just put in whatever your tail value is. So for the first one, 80%, looking at my table A, I found that it should be 1.28. And actually it's 1.282 to be exact. I know that our z-table only tells us 2 decimal places. If you use inverse norm, it's going to give you the 3, so I'm going to give them to you. For 90% of data, 1.645. For 95%, 1.960. Again, kind of close to 2, but we can see it was an estimation. And then 99% is 2.576. So within this amount of standard deviations of the mean, remember that within means plus or minus, so both the positive and negative direction. All right, so we're going to calculate the margin of error for a 95% interval by multiplying the critical value and standard deviation. So we are going to take the critical value for 95, which comes from right here. So critical value is 1.960, and we're going to multiply it by our standard deviation that we found. And now yours is a little bit different. Keep using your own. I found 0.0698. 0.0698. And for me, I got 0.137. So now, if I want to find my 95% confidence interval using my point estimate plus or minus the margin of error. So my point estimate is what I found at first, right? That is like my p hat. The margin of error is what we just found above. So I'm going to take my point estimate from before. You take yours. Mine's 0.42 plus or minus my margin of error, 0.137. And so what you're going to get is a range, right? Like a low number and a high when you do both the plus and minus. 0.42 minus 0.137 is 0.283. And 0.42 plus 0.137 is 0.557. Now, on the board, we want to go and graph this. So I already have drawn for you the number line. And it goes from like 0 to 0.1 to 0.15 to 0.2. So you can copy this on your paper. And you'll see it on the board as well. All right. Oops. 0.60. Okay. Now, what does this look like on the graph? I'm going to go with my lower end here, so 0.283, and estimate that would be about here. I'm going to go with the upper, which is 0.557, maybe about here. And I'm going to go and draw my actual point in the middle, which is at my point estimate. So I'm going to do the 0.42 right here. And that one I'm actually going to do a dot. And then I'm just going to draw a nice little line. So I show where my center is, and then I show my confidence interval. And really it means what it sounds like, right? It's like the interval over which I would feel confident the true value might lie. And then number 12, what do you think the true proportion of kisses that land flat is? Because I don't have all your classroom data, I can't really estimate this. So number 12 is one we'll have to talk about after we look at the class graph. You're going to collect data throughout the entire day, every single class. So that way tomorrow we can actually look at it all together and kind of find our best estimation. So now I'm going to go back over some of these important ideas and adding some notes. So now that we've come down here to margin of error, I do want to go back to question 6. So question 6, when we found the standard deviation of p hat, by using p hat, we actually were not finding the standard deviation of p hat anymore. We were finding what's called the standard error. And if you recall, this was on your formula sheet. It was like the one thing that we did not use from that row, SE sub p hat. It is your standard error formula. And we use that standard error formula to then come up with our margin of error. So the standard error, you can think of it as like your like standard for how much error you could have. The margin of error is like coming up with like how far off you could be from the truth, I guess. So the margin of error, often seen shortened as MOE, margin of error. Its formula is always the critical value times the standard error. So to write it a different way, your critical value is your Z times standard error is SE sub P hat. And the Z with the star is the critical value. All right, so now after we find our margin of error, we took the point estimate and we added or subtracted the margin of error. So this was my point estimate, or p hat, plus or minus the margin of error, which was found by doing the critical value times the standard error equation, which was p hat times 1 minus p hat over n. And this was used in order to find a confidence interval for a proportion. That's the whole point of today's lesson, to find the confidence interval for a proportion. All right, so again, we'll have to estimate together once I can see the graph. Let's just go ahead and do some important ideas. So we're going to have 3 of them today. So I'll mark off my thing into 3s. And I'll start with the first important idea. And so this first one is all about the conditions. So the first condition is it must be random. The second condition is the 10% condition, which is where your sample size is less than 10% of the population size. And the last one is to test for normal, and we use the large counts test, which is n times p hat greater than or equal to 10, and n times 1 minus p hat greater than or equal to 10. Since for these problems, we don't know p. All right, my second learning target is all about those critical values. So there are some common ones that we use very often. For the 90%, the critical value is 1.645. For 95%, the critical value is 1.960. And for 99%, the critical value is 2.576. Now, as we saw today, you could have also found it for 80. You could find it for other values if you were asked to. But these are some very common ones. Now, in order to find them for any percent that you might be asked, you can use inverse norm of your tails percentage, or inverse norm of 1 minus your confidence interval percentage divided by 2. Remember, because if you just do 1 minus, then that's everything that's not within your interval. But remember, the tails are on both sides, so you have to divide it by 2 so that it's for both sides. All right, and our last important idea for today is formulas for confidence interval for P, for proportions. So the first thing is your point estimate plus or minus the margin of error. That gets you your confidence interval. And that is your p hat plus or minus the z critical value times the standard error formula. So remember this right here. That is my standard error of p hat. So really this is all you need, these two, and then you find your interval of confidence and you are good to go. So go ahead and wrap up today by doing the check your understanding. make sure that you've got this down and note down any questions that you might have for me when we see each other again. All right, bye guys.